of offer, not a ton of manure. So biostimulants like us change the game. They actually
say drinking of water or moving to an air-conditioned room. I'm struggling for the past 2 days. How much more the plants that are on the crops that have no defense mechanism. And even if they have, it is quite limited to a certain way. And we also have genetic diversity. There's a lot of genetic diversity in terms of plants and animal, and we have poor soil fertility. Now, the issue of fertility is not necessarily due to the absence of the nutrients in the soil, but the nutrients might be present. However, the state in which the plants can easily utilize for production may not be present. And what I talked about earlier, the irregular rainfall patterns. You have an increased or decreased intensity in the frequency of rainfall. This year, what you observed was that the rainfall was very, very intense, but it was over a short period of time. So you realize that when the rainfalls were occurring, it was very, very intense. We were having pockets or issues of flooding across some of the farms. But all of a sudden, the rain stopped, and the frequency in which we wanted for our crops ceased. Usually, from the grains to that of the vegetables that we grow, we have a production cycle of between 3 to about 6 months. But it was relevant that this year, the rainfall that we had was not able to go for the full production cycle of our farmers, which caused a major problem. Now, we need to adapt. We have been hearing about climate change adaptability or climate adaptability. There's not only one approach, there's several approaches that can be used, right from the government to the research institutions, to the extension officers, to policymakers, and to the farmers themselves. There are various combinations that must be considered. So over here at HJA Africa, we're looking at the pathway. The first one is strengthening resilience and adaptation to climate change. We as a company, what can we do to help our farmers or strengthen our farmers' ability to be able to resist the negative effects of climate change? The next focus was, even though we are trying to help them to adapt to it, we should also aim to reduce greenhouse gas emissions and enhance carbon stocks, because this climate change is caused by the regular emission of greenhouse gases into the atmosphere. And also, the third pillar we are looking at was to increase sustainable practices to increase productivity. If you are able to bring all these plans and policies in place, however, if they are not sustainable, it will be difficult to achieve our aim. So, we all know OFA. This is OFA. You've seen, we said our tomato plant. Now, OFA is crucial in achieving future food security and climate change goals. It contributes to climate change mitigation through reduced inorganic fertilizer use, reduced maturity period for the crops, improved water productivity, and improved nutrient use efficiency. OFA contains important biological active components which enhance plant growth and tolerance to drought stress. So I won't disturb you with a lot of scientific machinations over here. So basically, we look at our treatments. So the control had no application of OFA or NPK. We had one that we applied only OFA. We had one that we applied only NPK. And there was one that we applied 50% OFA and 50% NPK. Now, our goal here was to subject the tomato plant to intense water stress. So over here, you can see a section of the field over here. What we have here is a rain shelter, which indicates that all the water available to the crops were what was provided by the research team. So which means over here, the amount of water we were applying, we intentionally subjected the tomato plant to a lot of water stress to mimic what was happening in the open field. Now, what we have here is a Class A water irrigation scaling pan. So this is the amount of, this is the reference point that we was using to calculate the amount of water to apply to the crop on a daily basis. Now we have the crop water requirement, that is the total amount of water that the crop will require to grow successfully within the growing season. It was calculated on a daily basis. So every morning, before we do the irrigation, we measure the quantity of water that has evaporated from the pan. Now, once it leaves, what to do is that we calculate the amount of water we're going to require to depend on the growth stage. But at the growth stage, each growth stage has its own particular crop water requirement. At the seedling stage, the amount of water we're going to require is less than the developing stage. And at the developing stage, the amount of water you're going to require is greater than the ripening stage or the harvesting stage of the tomato plant. So this is what we did. So for the purposes of this experiment, we reduced the crop water requirement by 40%. So let's say if it was in open field cultivation, the amount of rainfall or water that every year the crop was supposed to get, we intentionally reduced it by 40%, which means saluting the water, the tomato plant, to a lot of water stress. So you can see the various tomato plants during the experiment. As I said, these are rain shelter, which means apart from the water that we are applying onto the crops, no other form of water was getting onto the crops. So I'll move to the results. We did this for that of rice and that of tomato. And this experiment too was done in the coastal savannah zone of Ghana, that is in Cape Coast and in Accra. So we have the results for that of rice over here. Here we have our grain yield, and we have our water use efficiency. Now grain yield is at the end of the day after harvesting, the economic yield that we got from the crop. That is the part that we consume. That is the grain that we have over here. Realize that this is control. We didn't apply any form of NPK or offer. Over here, we had only 100% NPK, we had 100% offer, and we had a 50% offer and 50% NPK. Now realize that there was not much difference between either going only for NPK or going for offer. But rather, when you combine the two, it helps to increase yield. Now this is happening because, as our CEO said earlier, offer is a biostimulant, more or less like a blood tonic for human beings. Once we apply offer to the crops, it helps it to consume a lot of nutrients in the soil. True, it helps the plant to have a well-developed root system. Now, the root is responsible for absorbing a lot of nutrients from the soil, which means once the root system architecture is being improved, automatically the ability for the plant to uptake a lot of nutrients in the soil is also improved. And additionally to, as I said earlier, offer helps to convert a lot of fertilizer, let's say nitrogen in the soil, to forms that it can easily uptake in the soil. So that's why I like that if you combine that of offer and NPK, you are seeing a lot of improvement in the yield. Additionally to, offer brings a lot of benefits to the soil that NPK or inorganic fertilizer does not bring. It helps to improve the soil structure as well as helps to improve the soil health due to the increased activity of soil living organisms. And over here, look, you have the water use efficiency. Now, we are able to arrive at these figures by the total economic yield, that is the harvested rice that we had, divided by the total amount of water we applied throughout the entire growing season. So what about here is grams of rice grain per millimeter of water, which means each millimeter of water, how many grams of rice it is giving us. So as you can see, the control that we didn't have any application, you saw the performance over here. A similar trend was occurring over here, whereby 50-50 of both offer and NPK. The water use efficiency of the plant was high, which means even if you intentionally reduce the amount of water you're applying to your crops, because offer as a biostimulant has an ability to help the plant root system to develop more. And also, one good thing is that with offer, our trials realized that we're able to reduce the maturity period of crops. So for this experiment, we're able to reduce the maturity period of rice between 10 to 12 days. Now, this is the most important part. That is where the money issues are. But at the end of the day, we are all working to get money into our pockets. So this is the cost incurred. This cost may vary from one location to another location. Then this was the returns that we had from the trials that we did, and this was the net revenue, comparing it to the control. So when you're comparing that of only 100% NPK to that of the control, that we're having an increase in profit of about 4%. When you compare only offer to that of the control, you have a 53% increase in your net returns. And when you combine that of offer and NPK too, we are recording a 75% increase in returns from the rice production. So quickly go that of the tomato. Now over here, we have our 50-50. Over here, we have the 100% offer, the 100% NPK, and the control. So this measure over here is fruit set. Now fruit set basically indicates that the quantity of flowers that was present on the tomato plant that was able to result in fruits. Now we measure this particular because this is an important indicator for drought resistance. Usually, the causes of flower abortion is high temperature. With those of us who want to tomato production, realize that when the temperatures are high, we tend to observe a lot of flower abortion. Most of the flowers will be dropping due to extreme drought. So we measure this parameter just to see how the application of OFA alone, NPK alone, or combination of the OFA and NPK will help to get more yield in terms of the number of fruit, regardless of the amount of drought or stress that we were imposing onto the tomato plant. I realized that, obviously, the application of OFA alone, NPK alone, or the combination of the two helped to achieve higher fruit set compared to that of the control over here. Over here, too, you have the yield per tons, where there's like a similar trend in the rice. When you compare that of OFA and NPK, the highest yield was observed in that of OFA and NPK. In meaning that usually, when you apply organic fertilizers, it takes time for you to see the effect. The nutrient is released gradually over a period of time. However, for the inorganic, once you apply within a matter of days, you are seeing the effect. So the combined effect of instant impact of NPK on the vegetative growth and yield of the crops, as well as the slow release ability of the inorganic fertilizer, that is the OFA, the two of them combined to give us the better yield over here, compared to that of only 100% OFA and 100% NPK. Usually the control is something that usually we don't do in our farming system, because there's nobody who, especially in this room, who is going to cultivate tomato without any form of fertilizer application. So we just use it as a control for you to compare that. If you are doing 100% alone or NPK alone, it is better to combine both NPK and that of OFA. Over here we have our water use efficiency and we have the fertilizer use efficiency. So let me quickly go back to make this point. So over here, comparing to the control, 50% OFA and 50% NPK, we are improved our yield by 142% over here. But if you compare 50-50 of OFA and NPK to that of only 100% OFA, we are increasing it by 21%. And comparing 50-50 to that of only 100% NPK, we are realizing 43% improvement in terms of the yields. So over here, we have water use efficiency and we have fertilizer use efficiency. So basically, in terms of the economic yield that was realized, over here, we divided by the total amount of water that we applied for the entire growing season for us to help to indicate that whether the amount of water that we applied was able to give us enough economic yield. So that is the water use efficiency over here. And here you have the fertilizer use efficiency, that is the NPK and the OFA that we applied. In terms of the economic yield that we had, which one was more effective? So over here, we had this kilogram per liter. Every liter of water, how much kilograms of fruit is giving you? For every kilogram of fertilizer that you applied, how much kilograms of economic yield, the tomato fruit that you are getting from the fruit? It was evident that applying either solely NPK or OFA will increase your yield, all right? But if you combine both the NPK and that of OFA, it's going to improve the productivity of the plant. The last one over here is what we call the harvest index. Basically, it is a self-defense mechanism by the plant